everyone, happy Thursday. Just a reminder that there will be no assignments posted Friday and Monday since we are on a 4-day break for Easter. Happy Easter. Today I am going to go through these questions and help you with figuring out what the right answer is. Hopefully, you find this helpful. And let's get started. So we've got question number 1 here. It says, the 4 tables below show relationships in which the x values represent input and the y values represent the corresponding outputs. Which table represents a relationship that is not a function? So that's super important. So let's take a look at our boxes. Remember, to not be a function, in order for it not to be a function, there has to be multiple x's that are the same. Okay, because if it is a function, then all the x's are different. So if we look at table x, all those x's are different, so that is a function. Remember, we're looking for the one that's not. If we look at table r, that is also a function because all the x's are different. If you look at table s, all the x's are different, so that is a function as well. Whereas if you look at table t, I have duplicate 3's and I have duplicate 4's, which makes it not a function. So our answer here is going to be T. All right, let's take a look at the second question. Number 2 says, the table below shows the cost of different numbers of goldfish at a pet store. And based off of this, you want to identify which is true. So, the cost increases 30 cents each time a goldfish is added. Now, if we look for our rate of change, or how much it costs per goldfish, remember the rate of change is triangle y divided by triangle x. Okay, so my rate of change, in order to go from one y to the next, I do $3 minus $1.50, which is $1.50, all over my change in x's, which is 5. If I take $1.50 and divide it by 5, I get 0.3, or 30 cents in this case, because this is all cost. So the cost increases 30 cents each time one goldfish is added. Well, that's exactly what we just found. We don't even need to continue further. The answer is going to be the first one there. Okay. Okay, so question number 3. It says, tell whether the relationship in the mapping diagram is a function or not. So remember, for it to be a function, all the x values have to be different. Well, if I list these ordered pairs, remember it goes x comma y. The first ordered pair is -2 comma 5. Second ordered pair is -1 comma 5. Third ordered pair is 0 comma 5, 1 comma 5, and 2 comma 5. So my question is this a function? Well, are all of the x values different from each other? Yes, which makes it a function. Okay. All right, let me change my color here. This next one here, I think this is number 4. Yep. It says, decide whether the graph shown below is a function or not. Well, remember, in order for it to be a function, it has to pass the vertical line test. Okay, so let's draw a vertical line here. If it passes the vertical line test, it only touches, my line here will only touch the graph at one spot. However, in this case, it touches the graph at 2 spots, which makes this not a function. All right, let's look at I wish I numbered these ahead of time. Let's look at number 5. Okay, so it says solve for x. So this is an equation. This takes us back to what we learned last week. So I'm going to draw my line down the equal sign. There's no distributive property. There are no like terms. There are letters on both sides, so you want to get rid of the smaller one. So I'm going to subtract 5x on both sides. On the left side, the 5x's cancel and I drop down a -5. On the right side, 9x minus 5x is 4x, drop down the +3. And from here I have a two-step equation. So I'm going to subtract 3 on both sides, and I get negative 8 equals 4x. And then I'm going to get rid of the 4 by dividing it on both sides, and I get that x is equal to a negative 2. So in your box, okay, in the box there, you just want to write the number negative 2. Okay. Number 6. It says determine if each table shown below represents a function. Now notice here how in the picture there's like an answer spot for table 1 and for table 2. You can't click on those because that's an image. So you're going to still answer down below. Okay. So if we look, it is table 1 a function. Are all my x values different from each other? No, they aren't. I have duplicating 5s. So this is not a function. Whereas table 2, are all my x values different from each other? Nope, I have duplicating 7s. This is not a function. So table 1, no. Table 2, no. Is going to be your answer. All right. Number 7. It says pumps are used to empty water from 2 tanks, tank P and tank Q. Tank P begins with 65 gallons of water and empties at a rate of 6.5 gallons per minute. The amount of water in tank Q is represented by the equation y equals 63.5 minus 5.25x, where x is the number of minutes the pump has been emptying the tank. So which statement is true? And then it compares the rate and it compares the starting amount. So let's look at tank P, let's look at the first statement. Okay, and we're going to make some notes here. So we've got tank P begins with 65 gallons and empties 6.5 gallons per minute. Now, tank Q is represented by the equation here. Now, that's 63.5. That's my beginning amount. What they're subtracting there, that's how fast it's emptying. So it empties at a rate of 5.25 gallons per minute. So based on my information that I just wrote, let's take a look at the statements. So statement A says, tank P empties at a faster rate than tank Q. Does tank P empty faster? Does tank P empty faster than tank Q? Yes. Okay. And has a lesser starting amount than tank Q. Does tank P have a lesser starting amount than tank Q? No. So A is not the answer. So let's read answer B. Tank P empties at a faster rate than tank Q. Tank P empties faster than tank Q. That's true. And has a greater starting amount than tank Q, which it does. So my answer there is going to be B. I don't even have to worry about reading the other ones because I found the correct answer. Okay, number 8. It says, look at the data points on the graph. Is this relation a function? Well, you could list them or list the ordered pairs. Ordered pair A is going to be negative 3, 2. Ordered pair B is going to be negative 3, negative 2. And ordered pair C is going to be 1, 1. Is this a function? Which means, are all my x values different from each other? No, then it is not a function. All right, number 9. Which equation gives the rule for this table? Now remember, you want to write it in y equals mx plus b format, where m is my rate, or triangle y over triangle x, and b is my starting value. Okay, so here we go. So let's find first triangle y over triangle x. My pattern for my y's is 1. My pattern for my x's is 1. So my rate is 1 over 1, or 1. My starting value is my y value when x is 0. When x is 0, my y value is 2, so my starting value is 2. So my equation is going to be y equals 1x plus 2, which that answer would be the third one there. All right, number 10. Consider the function f of x equals 2x minus 1. Use the function to complete the following table. So we have an equation. Okay. And what we're going to do is we're going to plug our x values in individually to figure out what numbers get plugged into the table. So the work's going to look like 2 parentheses 1 minus 1, 2 parentheses 0 minus 1, 2 parentheses negative 1 minus 1, and 2 parentheses 2 minus 1. Okay, you can go ahead and type those into your calculator, and you'll get 2 times 1 is 1, 2 times 1 is 2, minus 1 is 1. 2 times 0 is 0, minus 1 is negative 1. 2 times negative 1 is negative 2, minus 1 is negative 3. And 2 times 2 is 4, minus 1 is 3. So we've got the answers of 1, negative 1, negative 3, 3, which if you look here, that's going to be the third answer. All right, number 11. 2 plumbers charge an initial fee and an hourly rate. The equation y equals 100 plus 3x, is plumber A, models plumber A's fee, where y is the total charge in dollars and x is the number of hours worked. The table shown represents plumber B's total charge for different numbers of hours. Okay, which statement is true? So let's identify real quick the information for plumber A. Plumber A's starting value is $100 and its fee per hour is $30. Okay, that's because that's the number that's attached to the X. Plumber B, which gives us the information from the table, its starting value would be what my y value is when x is 0. So let's go back in the table. Let's go back in my patterns here. My pattern, in order to go from 160 to 105, I need to subtract 55. So I'm going to subtract 55 again here in my table. So 105 minus 55 gives me 50. So plumber B's starting is $50 and its fee, which is triangle Y over triangle X, is 55 over 1, or just 55. So let's go ahead and take a look at our answers. So which statement is true? The 2 plumbers have equal hourly rates. Well, they do not have equal hourly rates. One's 30, one's 55. Plumber A has a greater initial fee. Well, is plumber A's initial fee, oops, wrong number, sorry, I highlighted. Is plumber A's initial fee greater than plumber B's starting fee or initial fee? Yep, that's exactly true. And then if you look at the third option there, plumber A has a greater hourly rate. That's not true. Plumber A's hourly rate's $30. And then that last option there is the 2 plumbers have equal initial fees, and that's not true either. And guys, that's it. So if you watched this video, you got all the answers, and hopefully you do well.